All right, hello everyone, welcome. Hope everybody's having a good day. Hope you're able to get out and enjoy some of this nice weather that we're having before it maybe goes away again. I hope not, but we'll see. I don't have too many announcements for you up front today, although I do kind of want to make sure you're generally aware of what's coming up in the next couple weeks for this class. Specifically, we're actually kind of cruising right along. Next week I'm going to introduce one more topic. So next Monday I'll introduce the topic of recursion. And then that's actually the last new topic that we're going to introduce before the next exam. So we actually have spring break this week right here, the week of the 10th. So this week and next week we have class, and then no class for spring break. But then the week that we get back from spring break is when our second exam is going to be on that Thursday. So just trying to make sure you're aware of that fact as you're planning. Should hopefully not interfere with anybody's spring break travel plans because it's on Thursday. Well after you should be getting back from spring break. But we will be doing the usual exam 2 review session and everything else. The only other thing that I wanted to make you aware of before we hop into today's topic is the fact that exam regrades. So you got your exam 1 grades back last week. If you want to submit a regrade request, I think the deadline is tomorrow. I don't remember what I said on Piazza. I think it's tomorrow. So please make sure you get that regrade request in if you need it. And I will get those back to you sometime this week, hopefully. So that's all I have for you for announcements. I'm going to go ahead and actually jump right into what we're talking about today because I want to spend as much time talking about this concept with you as possible. It's a game changer. We're really kind of stepping things up a notch today. So before I begin, let me point out that I posted some in-class review problems on Canvas. This is an Eclipse repository, so go ahead and if you want to follow along with me today, which I hope you do, go ahead and click on this link on Canvas for the Module 5 review problems. There's a few practice problems in there that I'm hoping that we'll have time to get to today, as well as some review questions that I'm going to start us off with. And let's go ahead and jump right in. First things first, I'm going to talk about the different parts of a method definition. So let's first even start talking about what methods even are, what they're doing for us. Before today, every program that you have written has followed the same basic flow. We start at the top and we work our way down towards the bottom. It's true that loops might have us, sit and repeat for a little while, and if statements might have us skip over chunks of code for a while, but the same general principle is applied of starting at the top, working our way towards the bottom. After today, that's not true anymore. After today, we're going to be jumping around all over the place. So we're adding an additional layer of complexity, actually, to our code. No longer is it going to be simple start at the top and just go line by line by line by line towards the bottom. There's going to be a lot more movement. There's going to be a lot more jumping around. The flow is not going to be as straight of a line, right, as it used to be. So that is complexity, but why? Hopefully there's a good reason, right? And we're not just making things more difficult for the sake of things being more difficult. There definitely is a good reason. These methods, all of the ones in the prep work, as well as the ones that I'm hoping to walk you through today, are defining some operation, right? They're defining some behavior. And by putting them into a method, that gives me the ability to reuse that operation over and over and over again. You might argue that, okay, I could have done that before, right? Copy pasting is a thing, and you're not wrong. But imagine you're in the situation where you think you've got something working properly, and you just decide to copy paste it, reuse it again. What if you were wrong? What if there was a mistake when you copied and pasted? You have now copy pasted that mistake. And if you copy paste that mistake a bunch of times, and guess what? You're going to have to go fix that mistake a bunch of times eventually. So as programmers, we really, 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 really love being able to reuse our code as much as possible. Instead of having to copy paste all over the place, that's a bad thing. Copy pasting itself isn't necessarily a bad thing, but if I'm copy pasting big chunks of code over and over and over again, I'm trying to train you all to think, maybe I should put this into a method and use that method over and over again instead. So let's start talking about that. Let's start talking about what a method is, how we can create and use methods in our code, starting with the parts of a method definition. We actually have a method on the screen right now. What method's on the screen right now? Main. Yeah, main. We're going to talk about main a little bit more, but since main is a method, we can use it to talk about the parts of a method definition. These first two parts right here, public, static, we didn't really explain too much what those are for. Those are kind of magic words at this moment in time, a little bit of hocus pocus, abracadabra. We will talk about these in a bit more detail as time goes on. But for now, even though it's perhaps a little bit unsatisfying, we're just going to treat this as the two words that we need to start creating a method definition. So these are a required part. Later on, we'll talk about what these actually mean and whether we can change them or not. But for now, we're just going to treat these as some magic words that we need. This next piece is something that was definitely in the prep work and something that we talked about. What is this an example of? Void is an example of return type. Good. Yeah, return type. So this is specifying what a method is going to output. So, I tell a method to do something, compute something, make something, right? And the method is going to, at the end, when it's done, say, here you go. Here's the thing that I computed, right? Where the thing that it has computed has to match, or the thing that it is returning, rather, has to match the return type. Now, this return type is actually a special one. That means this method doesn't return anything. We'll talk about that in a little bit more detail. That's one of my future questions down here. What does it mean to return something? So we will talk about that in a little bit more detail. But as far as part of the method definition goes, it goes public, static, and then return type is the next thing. So what might this be if it's not void? I mean, it could be literally any type you can think of. It could be an int. It could be a string. It could be a double. Right? It's a type. It is quite literally a type. Any type that you can possibly conceive of. Right? The next part of our method definition, this is the name of the method. And then finally, the last part of the method definition is what comes inside of the parentheses. Now, sometimes we might actually see empty parentheses. That's totally okay. But if there is stuff inside of the parentheses, what is that stuff? What do we call that stuff inside the parentheses? It's actually on the screen right now. The word I'm looking for. Yeah.
The parameter?
It's a parameter, yeah. And we can have more than one. If I want to have multiple parameters, I can just use a comma, right? And put in another parameter. Okay? So it's up to us to decide, right, how many of these we need to get the job done, to accomplish whatever task we are trying to accomplish at a given point in time. And then after we declare our method, we see our good friend curly braces, and then everything that goes inside of the curly braces is what the method is going to do. So we can put any statements we want to in here, if statements, loops, right, variable assignments, anything we've seen so far, and a bunch of stuff we haven't seen yet can all go, any valid code, any valid statements can go inside that method definition. So those are the big points. Really, the three main things are, this is what's coming out of the method, this is what the method is called, the method's name, and then anything in the parentheses, that's what's going into the method. So those are the big three things to pay attention to, aside from the other little parentheses and curly braces and stuff that you need. So let's talk about what arguments and parameters. So I often use this term interchangeably, although they are slightly different in terms of their definition. But let's just talk generally about what these are used for. Why might I include parameters here? What do the parameters do for me? Anybody have an idea? What parameters are for? So consider, actually, maybe it'll help if we consider, what if we don't have any parameters? If I don't have any parameters, I'm going to run this method. We're going to talk about that pretty soon. And it's going to run the same way every time. Right? It's going to run exactly the same way every time. It's going to start at the top of the method and work its way down towards the bottom. But if I include parameters, I can then use those parameters to help me make the method run a little bit differently depending on what the value of the parameters are. So the parameters of a method allow us to have more control over how the method executes. And what parameters you need is a tricky question. It really depends on what problem you're trying to solve, what information you have available to you. So this can be one of the tricky parts to figure out. But the purpose of parameters is to allow us to change the behavior of our method based on certain values, certain situations that may occur. This makes our methods more flexible, makes it so we can use our methods in more situations, which is a good thing. Again, I'm trying to reuse code as much as possible. Parameters help with this because it makes our methods more flexible, allows us to reuse our methods in more situations than if we didn't have parameters. All right, next up, what is a function call? Can somebody explain to me what a function call is? Just give me a plain English one-sentence definition. Or another way of thinking about it. We've talked about how to define a method. So I could actually come down here if I wanted to, and maybe we will in a little bit, come down here and make another method, right? And if I wanted this method to just be very simple, perhaps the most simple method of all, I could just have it say hello, right? Okay, so I defined a method using the rules that we talked about. Return type's void, there's no parameters, that's okay. Put some code in here. If I run this file right now, same thing gonna happen? There's a print statement. Is it gonna print hello? Let's try it and see. If I run this, nope. Nothing happens. What gives? I thought if we put print statements in our code, that means that we would see the result of the print statements come out at the bottom. Well, that has to do with the fact that this is just a method definition. I am describing a behavior. I'm telling you how to do something. Right? It's like if I have a recipe for making brownies, right? The recipe just tells me how to make the brownies. I don't actually have the brownies until I sit down and follow the instructions on the recipe to make the brownies. So this is a recipe, right? This is a description of how I perform a task, how I perform some operation. I have to say, okay, now do this thing, do this operation, perform the steps that are inside of this method. That's a method call. A method call is a way of saying, I want you to find the behavior that is called this, and I want you to do that behavior. So if we go, if we actually want to fix this problem of, why doesn't it print this message out? We have to call this method. We have to call this method. So where do we call this method and how? I'm going to do it up here in main. And the way that we call the method is to type the method name. That's the first thing that we do. And then parentheses. Always, 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 always need parentheses. Now, if there are parameters, right? If the method has parameters, if there are things inside of the parentheses, I have to say stuff here, right? So this method doesn't do it, but if I said string name here, then okay, I have to give you a string, right? I can't leave this empty. The method definition says that in order to run this method, I need a string. So when you call the method, that means you have to give me a string. It could come from a variable. It could come from you just typing in a string, right? It doesn't matter where the string comes from, but it's expecting a string. So you have to put a string inside of those parentheses, followed by a semicolon. And now if we run this program, since we're doing a method call, right? It'll actually say hello. In fact, I would like to show you the execution of this code in a little bit more detail. But first, I'm gonna skip down here to question number 6. do this a little bit out of order. What is the main method used for? Why did I put this method call inside of main? Why didn't I put it somewhere else? Does anybody know what the main method is used for in a Java program? It's a very clear, distinct purpose. So consider the fact that we're now going to have many of these methods in the same file, right? There's no limit. I can put 10 of them in here. I can put 100 of them in here. That's a little extreme, but I could do it. Eclipse wouldn't stop me. So where do I begin? Which one do I do first? If I have 10 different things, right? 10 different methods, which one do I do first? Well, the answer to that is main. Main is always first. The main method is the entry point to the program. It's where we begin. The first line in main is the first line that will run. Okay? So, if we think about this very simple program that we have right now, right? The first line in main is the first line that's going to run. This is the first line that's not a comment, right? This is the first actual line of code. What is this line saying? It's saying go run the operation, the method that's called another method, and here's your parameter. And so it's gonna say, it's gonna jump down here and say, you told me to do everything that this method told me to do, and it'll do this. But let's run it through the debugger and actually, take a look at what happens in a little bit more detail. I'm going to set a breakpoint right here on line number 13, and then start up the debugger. Okay, so here I am, paused on line 13. Notice that I am in the main method. It's the very first line of the main method. I want you to take a look at this over here on the left-hand side. In the debugger, we have what's called the stack, the method call stack. This keeps track of all of the methods that we travel to, and also helps us get back, right? Go back. So when you look at this method call stack, you're always going to see main at the very bottom. When I call a method, it gets added to the stack, and it's called a stack for a reason. Main is on there first. It's the very first method I start at. The new method's going to get added to the top of the stack. And then if I call another method, it's going to get added to the top of the stack. And if I call another method, it's going to get added to the top of the stack. But I think what's also important is what happens when a method is finished, right? What happens when a method is over? What do I do next? So let's see what happens. Notice that if I am in this, I'm on line 13. Before today, the only debugger option that we've really talked about is step over. Notice that if I click step over, what happens? Oh, boom, it ran everything in the method, and it looked for more code to do, but that was actually the only thing in main, so it says we're done. But hold on a second, I didn't actually get to see this run. Like I want to see the flow in a little bit more detail. So let me stop this and restart this in the debugger and show you another option that you have at your disposal that's going to come in handy when using methods. So this one is step over. That's what we've been using to go line by line. But if I'm dealing with a method, it's important to consider the one that's right next to it that's called step into. What this is going to do is it's actually going to take me to this method and let me walk through that method line by line so that I can make sure that that's executing properly. Let's give it a try. I'm going to click this button and boom, here we are. Take a look at the stack over here. We started in main. Now we're in the method that's called another method. So look at where it is. It's on the top of the stack. Whatever method is on the top of the stack, that's where we are right now. That's what we're doing at this very moment. That's what's being executed. But it's keeping track of everywhere we've been from main until that point. Even if I go through 10 different methods to get here, I'll see all 10 of them on the stack. And that's important because where do I go after this happens? Well, I'm going to look at the stack and say, I was in main. I want to go back there. And more specifically, where am I going to go back to in main? I'm going to go back to where I started from, line 13. I'm going to go back to line 13. Okay. So if I continue to step, we'll see that this method is over. It has finished its job. And we're going to jump back. Now, well, it tried to jump back to line 13 and keep going, but there's nothing to do. So it hit the end of the program. There's a name for what we just did. When I jumped to this method with the method call, and then I go back to the previous method, there's a name for that. Anybody know what it's called? What we just did? It's actually on our list of review questions a little bit later down. What's another word for going back where you came from? It starts with an R. Return. We just performed a return. We just performed a return. When a method is over, it is going to return. So return actually means two things. In this case, it means return from where you came from. Let me actually see if I can tweak this example and show you that in a little bit more detail. What if I call this method again? I can put a different name in here if I want to, like my daughter's name, for example. And I could even call it a third time. Put my son's name in here. If I run this through the debugger again, let's take a peek and see what happens, right? I step into the method. I print out the word hello. And then it says return. Where do I return back to? I'm going to return back to line 13. So the line that I go back to is line 13. That's what it says right here in the stack. And where do I go back to? I went back to line 13, and I'm getting ready to execute the next line, right? Okay, well, I can step into this method, and if we take a look at the stack now, notice that I'm in the same method as I was before. It's doing the same thing as it did before, but look at the stack now. It says, okay, when you return this time, you're going to go back to the main method, but this time you're going to go back to line 15, right? I return back to where the method was called. I return back to where the method was called. Always, 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 always. And how does it do that? It looks at the stack. When a method is over, it says, where do I go now? Oh, I go to main, line 15. And it goes to main line 15, and it tries to keep going. Okay, great. So I'll step through, and one more time, right? Now I'm on line 17. If I step into this, we take a look at the stack, right? You can see that when this one's done, it's going to return to line 17. Everybody with me? Any questions about that? It's a very important, very, very important concept, very important idea. The flow is no longer a straight line, right? It is a straight line until I call a method, and then it's go to that method, do that thing, and then come right back here, and then keep going in a straight line. Oh, go to another method call, go to that method, do that thing, and then come right back here. But sometimes it might be even more complicated than that. It might be go to method A. Method A says go to method B, right? B is going to return back to A, and then A is going to return back to where we originally started from. And it can get even more complicated than that, right? The sky's the limit in terms of how many methods I can call and what order I can call them. And that's up to me as the programmer to decide. All right. One thing that I kind of want to illustrate before we finish up this review and get back into some of these practice problems. Notice that I'm plugging this parameter in, but I'm not actually doing anything with it. So it's not actually changing the execution of the code. This is bad. This is a bad thing. If you find yourself in this situation, you have one of two options. You either need to get rid of this because you're not using it. It's just taking up space. It's not helping. If anything, it's getting in the way. Or you need to use it. You need to incorporate it into the method. So if I wanted to, I could actually do some concatenation here and tack this name on the end, right? And that makes this method perhaps a little bit more useful, a little bit more generally applicable. You can see now that the way that this method is going to operate depends upon the parameter that it's passed. It is going to say, hello directly to the name that's passed in, which I can show you by running it, right? So now this method has arguably become more useful and more applicable to more situations. That's a good thing. Parameters help us use methods in more situations. That's what we want. Scope. Let's chat about scope, and then we'll chat about returning one more time. Scope. What is scope? Can somebody define scope for me in just a sentence, perhaps? Yeah.
It is a range that within the variable can be visible and accessible.
Yeah, a lot of great parts to that answer. The range in which a variable is visible, accessible. Yeah, it's the parts of the code in which I can see a variable, right? So this is going to start mattering a lot more to us now that we have methods. In the past, we were doing everything in main, so I could probably see all of my variables all the time. But that's not going to be true anymore. The big thing to keep in mind is that if I create a variable within a method, I cannot see that variable in other methods. So for example, if I create a variable in my main method, int x equals 7, right? Doesn't matter. Let me run this in the debugger one more time and show you, right, that, okay, over here I see that I have a variable called x, and it's equal to 7. That makes sense to me. But as soon as I go into this method, as soon as I call this method, you can see that it does not know what x is anymore. X does not exist within this method. It cannot see this variable. It has no idea that this variable exists, cannot access it, cannot do anything with it. That's actually, I would argue, a good thing. It helps us keep our methods focused. If I wanted to get this variable into this method, what would I do? How do we put stuff into methods? So where we've been talking about a lot today. Starts with a P. If I really want to feed something into a method, I'm going to tack on another parameter. I can have as many parameters as I want. So if I need to feed stuff into a method, that's what the parameters are for, right? It's not just going to magically transport all my variables to the method. Only the variables that get passed in as parameters are the ones that I'm going to be able to see. And similarly to that, I mean, keep in mind what else this implies, right? That means that actually, okay, I can have this int x equals 7 here, but I could also, if I wanted to, say int x equals 2 here, and it's not going to complain. This is not the same variable x that this is. They are two distinctly separate variables called x that exist in two distinctly separate scopes, and that's okay. We can do that. There's no interference between those two variables, right? That's a good thing. You can actually view this for yourself in the debugger by seeing that, okay, when I'm in main, the value of x is 7, but as soon as I step into this method, you can see that, well, x doesn't exist until the very next line when it gets created. Now x is 2, but when I leave this method, when I return and I go back to main, well, look, x is 7 again, right? So there are two copies of x, one in main and one in the method that I created. How do I know that that is in fact the case? What dictates the scope of a variable? What tells me when I can access a variable or not? Something that we've seen a lot. Something that's on the screen right now. It's a piece of, it's one symbol, I would say, or a pair of symbols. Think about what we're using to say what's in a method or not. As soon as I hit this bracket, I can't see this variable anymore. Or in other words, because I created this variable inside of these curly braces, that's where I can see that variable. That's where I can use that variable. As soon as I leave those curly braces, that variable is no longer accessible to me. The scope of a variable is defined by curly braces using the rule that I just described, right? If a variable is contained within a set of curly braces, it is only visible within those curly braces. And think about what that means. We've actually seen curly braces being used before today, right? With if statements and with loops. If I create a variable within a loop, I can only see that variable within that loop. As soon as I leave the loop, I can't see that variable anymore. Some of you have maybe already run into that situation, right? It's a pretty common way that people run into this idea of scope. That's why a lot of times we create our variables outside of the loop, right? So here's another instance of curly braces defining the scope of a variable. And last, but certainly not least, before we do some exercises with the rest of the time, let's talk about this return concept again. So I said that it means two things. The first thing that return means is return to the method call is done, right? When a method is finished, return says go back to where this method was called and then keep going. So that's the first thing that a return does. The second part of a return only applies when when the return type is anything but void. So a return also says, it also specifies what the return value should be. So if I want to create a very, very simple example to illustrate return values, I'll say, this is about as easy as it gets. We don't need a method to do this. We could just use addition, right? But I'm trying to illustrate how return values work. If I have a return statement, the return statement says two things. It says, go back. The method is over. We are done. Go back from where you came from. And it also, in this case, because the return statement is not void, says that this is the answer. Or maybe another way of thinking about this, would be like expanding upon this out a little. You don't need to do it in 2 lines, but just illustrates the concept a little bit differently to break it up like this. And let's try it out too, and see what happens, when we try to use this. I'll say add 2 ints with like 2 and 7. Okay, I want to walk through the debugger and see what happens. See this return process in action. I'm going to turn this breakpoint off because I'm kind of done with this one, and I'm going to set my breakpoint here on line 20. And see if we can get these 2 ints to add together properly. So here I am on line 20. If I step into this method, I can see my parameters for A and B as 2 and 7, right? You see those? That's nice. I'm going to add those together, and then it says to return the sum, which is 9. So yay, it did the addition properly. But what does it mean when I say return? We'll take a look at this statement right here. It says add 2 ints returned a 9. Now there's a little bit of an issue, I think, with the way that I did this. Where does that 9 go after this? Well, it just kind of goes poof and disappears. I'm not going to see it. I'm not going to have access to it, right? This has returned the value of 9 to the main method. So it went back to main and it took the value of 9 with it. But if I want to keep that value, I need to store it. I need to put it somewhere. I need to give it a name. I need to make a variable for it. So when you see methods that use return types, for void methods, I often use them just like this. Just call the method and you're done. But if there is a return type, if there's a return value, as there is in this case, then to capture that return value, you want to make a variable. So take the value that's being returned from this and put it into this variable. And so now I can then, if I want to go on the next line and print it out, or pass it into another method and do some future arithmetic with that variable, right? Whatever I need to. But remember that I can't see variables in other methods, so the only way that I can communicate values into and out of my methods are via the parameters and via the return type. Also notice that unlike parameters, my return value is kind of limited. I can only have 1. So I can have as many parameters as I want. but I can only return one thing. That might seem like a pretty difficult limitation. There are ways of getting around that, and we'll talk about ways that we can get around that limitation later on in the semester, but that is an important rule to keep in mind. I can return one thing, or 0 things, right? That's also an option. But that's it. Those are my 2 options. I can return one thing or 0 things. But yeah, if you run this code again now, run it through the debugger one final time, we can see that, okay, now when I get to line 20, this time when I execute the method, oh, look at that. It returned a 9 and stored it in the variable called value. And I now have access to that value, and I can use that anywhere else in my code that I want to. Print it out, do more arithmetic, whatever the case may be. We've hit the highlights, I think, of what I think are the important concepts from this module, from this section. Does anybody have any questions for me? Anybody want me to go through any of these concepts again, explain them again? Okay. Does anybody want me to go through any of the exercises from today? There are a few exercises that you were asked to take a look at before coming to class today. Are there any of these that any of you would like to see me walk through? If not, I brought some more exercises for us to work on. Yeah?
I have a question on one of, it's like in the reading that you post on Canvas.
Uh-huh.
It's from the writing methods.
Mm-hmm.
And I think it's 5-1-10.
Okay. Okay. Yeah, what's the question?
I'm a little bit confused on how the control returns to line 16.
Okay, so if we want to follow the path through these methods, right, we're going to start from our main method right here. The first thing that it says to do is to go to M. So let me make sure I understand what the question's asking. After line 12 executes. Okay, cool, got it. We're going to go to M first. It's going to say called M. Then it says go to N. So it's going to N. Boop, we go up to N. It says I'm in N. Here I am in N. And now the question says, where are we going to go back to? So if we look at the stack, it's upside down compared to how I was showing it to you before in Eclipse, but this is the same thing, just flipped as the stack over here. It's the exact same thing. So the question is, where do we go back? And the answer is always going to be look at the stack and go to where it says to go back to. So how did I get to N? I got to N through line 16 in M. So when I am done running N, I'm going to go back to line 16 in M. That's what the stack says to do. Always follow what the stack says to do. Always go back to wherever the method was called. You'll notice that N is also up here, so they maybe thought that you might get confused and try to go back to line 6, but that would only be the case after first visiting O and then visiting N, right? So there's actually 2 different ways that I can get to this N method, but when I return, I always go back from where I came from. I'm never going back to a different place. Always go back to where you came from. Great question. Any other questions? Any other stuff from the prep work? Any exercises you want me to do before we hop into some more practice? Yeah, in the back. The shipping cost calculator. Okay. Awesome. Yeah, I'd be happy to do this one. This is a great example. Thank you for asking me to do it. This is a great situation for when I hope you would consider using methods, right? I see that I actually have the same chunk of code basically written 3 different times. This looks like a case where we copy pasted something 3 different times. And so this exercise wants us to add a method that has one parameter and then use this method to replace all of these redundant things that are happening. So let's do that. Let's go down, and first thing I'm going to do is create the method. I'll say public static. The next thing I need to decide is the return type, the return value, right? So let's think, does this need a return type? If you're unsure, as I sometimes am, you can always just start with void, and then if you decide later that, well, okay, maybe it actually does need to return something, I can always come back and change it, right? So starting with void is not necessarily a bad idea. You can always come back and change it later if you need to. I'll say calculate shipping. That's the name of the method that they told us to create, and they even gave us a big hint that says that it should only have one parameter. Okay, what should that parameter be? If I look at this code, it looks like it's choosing the cost based on the weight, right? And every single one of these cases, it's choosing the cost based on the weight. So the weight is what is dictating what gets printed out. So I think that's going to be my parameter. Inside of this method, I now need to basically do this, but I'm going to write it in such a way that uses my parameter. So I could say if weight is less than 15, and actually, you know, here I would say what cost is equal to $9.95, or I could actually skip this and say I could do this a little bit differently. I could say return 9.95. Does that make sense? I would then have to switch my return type. It's not void anymore. It should now be double. But hopefully it makes sense why this is okay, right? If the weight is under 15, then the shipping is going to be $9.95. That's the answer. Remember, this statement says 2 things. It says this is the answer, and also I am done. Stop this method. Get out of here. Go back to where you came from. For the else statement, we would see something similar where I would just return $12.95. Oh, wait a second. This is kind of interesting. I've got 2 return statements in the same method. That's okay. That's all right. It's totally fine. But I have to guarantee that I'm going to hit at least one of them, right? I said that I was returning a double. I can't just not return a double. I can't just not return something. I have to return a double. Yeah, question.
What happens if you return 2?
What happens if I return 2? Well, 2 can be converted to a double, even though technically it isn't int. So it will happily turn that 2 into 2.0 and move on with its day for you. Yeah, it's a good question, but doing something like this is right out, right? That's not going to fly, obviously, I hope. But what's perhaps a little bit less obvious is like, what if I just don't return at all? What if I do something like this? This is actually a pretty common mistake that people make. Instead of returning a value, they will print the value. Printing and returning are 2 different things. Printing and returning are 2 different things. Printing shows something on the screen. Returning a value does not show anything on the screen. It simply moves a value from one place to another place. So a return is only for programmers, really, right? Return is just so programmers can move data around and get the information where they need it to be. Printing is so we can actually see it, which is a different situation, different scenario. Sometimes I want to do both. Sometimes I want to return and print, but don't confuse one for the other. In this particular case, the error is going to say something like, it must return a result of type double. And if I take the else path, notice that I will never hit a return statement, right? That's not allowed. I have to guarantee that I'm going to hit a return statement. If I say that the return type is anything but void, then I have to give you a value. It is non-optional. It has to return something. So be careful about that. I would say return $12.95 down here. There are certainly other ways you could do this. So if you came up with a different solution, great, awesome. I think that's fantastic. This is not the only way to do this. This is just the way I've decided to do it. But now we get to come back up here and hopefully, replace a lot of this stuff with the methods that we've called. So for example, I can take this whole thing out and do a method call here. I can say calculate shipping. I need to plug in the parameter, right, which is going to be weight 1. Now be careful, this isn't going to print anything. It's going to return a value, and if I do something like this, oh, I already did that, so I don't need, it was already declared up here, so I actually don't need to put the type on it again, but otherwise, there we go. Run the method, store the value into a variable, and then print out that variable. And guess what? We're going to do the exact same thing basically for 2 and 3 as well. Boop, boop, and just switch these to say 2 and 3. Oh, these as well, huh? There we go. And now we have completed this exercise, I believe, right? Notice that, that repetitive chunk of code has been replaced with method calls. This is good programming. I am now reusing this same chunk of code multiple times instead of having that same chunk of code pasted multiple times. That's a bad thing. I don't like to see that. Anytime I see something that is repetitive like that, my brain thinks, oh, there's a method here somewhere. There's definitely a way to repeat this using a method somehow. Any questions on this problem before we try some other ones? Or any other examples that you would like to see me go through before we try some other ones? Happy to do more if that would help. All right, I brought some exercises with me to work on for today. They kind of go from easiest to hardest, so we're going to start with the easier one, and hopefully we'll get time to go through all three. We'll see how things go. But the first exercise wants you to write a method that takes in an array. Oh boy, here we go. An array of integers and returns the sum of the first and the last values of the array. So I kind of want to help you out with this one a little bit, right? Think for a second that we need to call this method, and sometimes it can be useful to write the method call first. So I might do something like, say sum of first and last might be what I want the method to be called. Okay, it needs to take in an array of ints, right? So let's make an array of ints. We know how to do this. Test array is equal to 1, 2, 3, 4. Boop. Come on now. There we go. So I'll go ahead and plug in my test array here. It says that I want this to return a value, and specifically for this very simple example that I set up, it should return a value of 1 plus 4, which is 5. So, okay, let's make a variable to store that return value and then finally print it out. Here we go. This is the code that we need in the main method to check and make sure that it works. We wrote the method call first before we defined the method. But now I'm going to turn you loose on writing the method itself. There's a lot of good information here, right? You can actually kind of reverse engineer what the return type is, what the parameters should be. The method itself, like the body of the method, very short. This one should only be a line or two. For this particular example, I'm going to give you a few minutes. Talk to your neighbors. I'll do a lap or two if you get stuck or you need any questions. But I'll regroup us around 1:55 or so and go through this solution, and then we'll do another one after that. Let me know if you need any help, okay? Alrighty. Saw some good answers. Heard some people. Sounds like they got the right result, which is great. Love to see that. Let's walk through the solution, make sure we're all on the same page, and then we can try a little trickier one after this, perhaps. First thing we need to do is declare the method, right? So remember that all of our methods are going to start with the same two magic words, at least for now, public and static. And then the next thing to decide on is the return type. But I kind of told you what that was, especially when I store the return value into a variable like this. I mean, this is always going to match the return type. It has to, right? It has to be the same, ideally. So the return type in this case is going to be an int. I mean, that also makes sense because I'm adding two values from an array of integers together. So that's also going to be an int, right? The solution should be an int. The next part of the method definition is the name, and you could have chosen a different name than me if you wanted to, but this is what I chose to call this method, so that's what I'll use as the name here. And then I think what might be perhaps the trickiest part of this method definition is what goes inside of the parentheses here. It needs to take in an array of integers. An array of integers. So the first thing that I see a lot of people try is maybe something like this. And you're close, but this isn't an array of integers. This is just one integer. How do I make this an array of integers? Brackets. We got to put brackets here. Any type can be used here, right? So if I want to put an array of doubles, array of strings, array of whatever, right? That's a type. That's a valid type. I can use that as a type for my parameter. Okay, now we just have to make it do the thing. Now we just have to make it get the first value out of the array and the second value out of the array and add the two values together. You can actually do this all in one line, but I certainly wouldn't mind if you broke it up a little bit, into chunks. You could say, int first. This is usually the easiest one. It's always going to be in position 0, right? The last value, a little bit tricky. What's the address of the last value? Somebody help me out. What's the index for the last value here? The length minus 1. So we got to grab the length of the array and subtract 1 from it. That's maybe another little tricky part. And then finally, we're going to add them together. First plus last. But this is our answer, right? This is our return value. So don't forget to put the return out in front to indicate that this is the answer. This is the sum of the first and the last value from the array. Any questions about this one? You definitely can do it in one line if you want to, and if you did, great. I think that's cool. If you broke it up and did it like this, I think that's also cool. Question?
How are you extracting values from the test array?
Great question. Yeah, so let's talk about that for a second. Because when I call the method, I plug in a thing called test array, but this isn't called test array, right? It's called array. Well, you can actually think remember that the scope applies here. This is created within main, right? I cannot see this from down here, right? However, this is a parameter, so I can definitely see that. There's an implied sort of assignment statement going on where I'm saying that this is equal to this. Does that make sense? I hope. These are two different variables, right? This variable only exists within this method, and this variable only exists within this method. But by plugging this in as a parameter, right, I'm doing an implied variable assignment that says this is equal to this. Does that make sense? I hope. I hope. And this is another good time to run it through the debugger if you want to see kind of a little bit more detail about what's happening. Right now, I'm within the main method, and I can see my test array with the values of 1, 2, 3, 4. As soon as I step into here, notice that test array is gone. I cannot see that variable, but I can see my array parameter, which looks exactly the same, and that's because of that implied assignment that's happening, right? This was set equal to this when I plugged it in as the parameter. Great question. Any other questions before we do another one? Yeah. Where's the return value being stored? In the main. So this method returns something. In order to store a return value, I'm going to put a variable declaration in front of it. So whenever my method has a return type, you can ignore the return value. If you truly do not need the return value, you can ignore it and just throw it in the trash, essentially, right? Just say, I don't need this, and toss it out. But if you want that return value, and this is by far how I use methods 99% of the time, if this method has a return type that is not void, I'm going to make a variable that is the same thing as that return type and set it equal to that method call so that I can remember to capture that return value. 99 times out of 100, that's probably what I'm going to do. Any other questions? I think we're only going to have time to do one more. I do have a couple more for you to do, but I think we're only going to have time to do one more, and I want to do this one. I want to do a method that's going to add two arrays of ints together. This one is a little trickier. The amount of code that you're going to need inside of the method is going to be a little bit more than the last example. But just like the last example, let's try and get things set up so that we're all on the same page. Whoops, I forgot the void here. Why don't we just try and recreate this exact arithmetic, right? I'm going to make this array, I'm going to make this array, and I'm going to try and add them together to get this. Let's try and set up the method call for that. Array 1 is equal to 3, 4, 5, 1. Array 2 is equal to 1, 6. Notice, right, that these are not the same length. So the 1 gets added to the 3 to make 4, and the 4 gets added to the 6 to make 10. But since this array is longer, it just copies these values. It adds 0 to them, essentially, right? Since there are no more values in the shorter, I ran out. So that's definitely a wrinkle that you need to think about when creating this method. So the method is going to be what? Add arrays. I'm going to plug in array 1 and array 2. And the result that I get back should also be an array, right? An array of integers. So I'll say int result. This result, I'm hoping, will look like this by the time we're done. In order to verify that, what do I have to do? If I want to see the contents of an array, what do I have to do? I heard somebody whisper, traverse. Yes, we have to traverse the array. That's correct. We have to traverse the array. All right, do the array traversal to print out the results. Just like last time, you don't need to mess with this code anymore. This code is good for calling the method. You just need to make this method itself. Little trickier than the last one. I'm going to give you a good somewhere between 5 to 10. I want to make sure I have enough time to go through the solution with you, so I'll probably call your attention around, I don't know, 2:10, 2:12, something like that. Take a few moments, talk to your neighbors, see how far you can get on this problem before we wrap up for today. All right, I love to see you all working on this problem. Lots of great conversations happening in the room. However, we only have a few minutes left, and I want to make sure that you have a solution to this problem before you walk out of the room today. So let's spend the last few minutes walking through this. I'm going to show you my solution. I definitely saw a lot of different paths being taken, and that's great. There is not just one way to solve this problem. There are multiple ways to solve this problem, but let's talk about a possible solution. Starting with the definition of the method itself, I think one of the first things, tricky things, is the return type. Again, just saying an int here isn't enough. The result of this method is not one number, it is multiple numbers. It's a collection of numbers. So the return type really needs to be an array of integers, right? Again, it needs to match this. It needs to match whatever I'm using to store the result. Once we get past that, we'll type in the name of our method, and just like we saw in the previous problem, right, our parameters are also going to be arrays. So I'll put in, int array 1 and int array 2, and And we're now ready to start tackling the actual problem of adding these two things together. Okay, one of the things that I heard a lot of people talking about, and is of course one of the trickier parts of this, is the fact that these arrays do not have to be the same size. They don't have to be the same length. And one thing that you might say is, well, okay, this array is longer than this one, so I'll just take that into account. But is that always going to be true? Not necessarily, right? When I write a method, I want it to be useful in as many situations as possible. And if could I write a method that assumes that this array is always going to be longer than the second array? I could, but I would argue that that is not as useful as a method that does not make that assumption, right? I don't want to assume that this array is going to be longer than this one or not. I want to make that determination myself. I can ask which array is longer, right? I can ask that question and figure out that answer, because that's going to tell me how long my result array has to be, right? That's going to tell me how long the answer array has to be. So let's figure that out. Int max size is equal to, we can assume perhaps that, all right, let's assume that the first one is longer, and then I'll say if 2.length is greater than 1.length, then my max size is equal to 2.length instead, right? Does everybody see what I've done here and how this works? I'm just trying to figure out which array is longer, which array is bigger. Once I've figured out which array is bigger, I can make an array to hold my answer. So let's do that next. My result array will be a new array with max size, right? It's going to be the same size as the longest one, because I know it's going to have one entry for each of the longest ones. And now we have to do the actual addition itself. Consider that we can so I'm calling this addition, but we can actually do the addition here if we wanted to. Or in other words, the way that I'm thinking about solving this problem is this array is going to start out empty as all zeros. I'll add the 3 to it, right? And then I'll add the 1 to it, and that'll get me 4. And then I'll add the 4 here, and then I'll add the 6 here, and that'll get me 10. And then I'll add the 5 here, and then I'll somehow need to determine that I don't have any more values here, right? But actually the same could also happen in reverse. So it could be this array runs out of values first, right? Instead of the second one. So I actually need to be careful about that for both of them. But in either case, I think I need a loop to iterate through the max size. And inside of this loop, let's take care of this case first, where the second array is shorter than the first array, even though it's going to be similar in the opposite direction. If I is less than 2.length, I will take, that means that there is a value, right? If I is less than the length of this array, that means I still have more values, right? There's a value at position I that I'm allowed to access, right? Everybody see that? So I need to take that value and I need to put it in I need to add it to my result. I'll do a plus equals to at I. Oh, whoops, except I need to say result at I. Sorry. Result is an array, so I have to use the square brackets for it as well. Forgot that step. And surprise, surprise, actually, I'm just going to repeat this process for the first array as well. And that way, if I run out of values from the first array first, then I'll just start skipping them. And if I run out of values from the second array first, well, I'll just start skipping those. Question, could this be an else if? Could this be an else if? See some people nodding their head yes. Is it ever the case that both of these things will be true? What happens if both of these things are true? If I is less than 1.length, I'm going to copy this over, and because this is an else if, this would get skipped. Well, wait a second, I don't want to skip that. I want to do this. I think these need to be two separate if statements. If I haven't run out of values from the first array, copy them in. If I haven't run out of values from the second array, copy them in. And then finally down here at the bottom, when I'm all done, I'll return my result. Let's run this and see if it actually works. 4, 10, 5, 1. So that actually does match the 4, 10, 5, 1 that I was expecting for this example. But that's not a good enough test. I think we also need to test it right with the short array first and the long array second, right? Because that should get the same answer back out. Just because I switched the order it shouldn't change anything addition-wise, right? Should get the exact same order back out, the exact same values back out, and boom, there it is. So all of this checking about the size, which one is bigger, is necessary. You can see this is a bit more complicated than the original example that we saw. Walk through it in the debugger. I wish I had time to do that for you now. That would be my next step if I had more time, but I don't. We're out of time for today. Walk through it in the debugger. Make sure you understand this. It's on the video that's being recorded. Let me know if you have any questions, and have a good rest of your week, okay? Yeah, what's up?